This is a video about electron dot structures. You guys probably remember doing these, I think, as a ninth grader, but I still want to teach it to you again. So first of all, we've talked about valence electrons a little bit, but just to remind you, and you might want to put this in your notes, that valence electrons are the outermost, highest energy level, so the biggest N value, S&P electrons, and those are the ones and the only ones that are involved in chemical bonding. So the outermost S&P electrons are the valence electrons. So I want you guys to pause me and go get your periodic table if you don't have it. So what we're going to do is we're going to label our periodic table. So if you remember, back to this worksheet, which you're also going to need. These guys here were all in group 1 of the periodic table, and they all ended in S1. So on your periodic table, I want you to write 1E here, because there's one valence electron in that group. The next group on that worksheet right here, this is group 2, and they all end in S2. So back to our periodic table, we would put 2E here, because it's 2 electrons. Then we get to, and we're going to skip the middle, the D block, because those ones don't necessarily behave where we can label just the column entirely. So what we do is we focus on just the S and P block for this. So this is group 13, and notice that they have 3 valence electrons, so 2s plus a p. So if we go back here, we would put 3 valence electrons. And then we get to group 14, and there's a total of 4 valence electrons for all of them. So we would get over here and put a 4 here. And we can keep going. So then when we get like here, this is group 15, we have 5 valence electrons in all of these. Group 16, we have 6. Group 17, we have 7. And group 18, we have 2 for helium, but otherwise we have 8. So let's go back. So we would put 5 electrons for group 15, 6 for group 16, 7. And then I'm going to put 2 valence electrons for the helium, and then on top of the neon is where they would all then have 8. So now we're going to go and talk about the electron dot diagrams. So these I think you've done, but again, I'll just pretend you haven't, just in case you don't remember. And then your other teacher may have done it differently than me too. So what we do is we write the element symbol, and then we're only going to represent the valence electrons, because those are the ones that are most important in chemistry. They're the ones involved in all the bonding and chemical change. So here's some examples. We also call these Lewis dot structures sometimes. So lithium, if I go to my periodic table, lithium has 1 valence electron. So I'm going to start at 12 o'clock, like this is a clock. And then I'm going to do the next. So I'm done with lithium. It only has that 1 valence electron. Aluminum is over here. So this has 3 valence electrons. So when I do aluminum, I'm going to go 12 o'clock, 3 o'clock, 6 o'clock. Chlorine is right here, and that has 7 valence electrons. So I would like you to do it this way: 1 o'clock, 2 o'clock, 3 o'clock. I mean, I can't talk, sorry you guys. 1, 3, 6, and 9, and then I'm going to double them up. Sorry, it's been a long day. So there would be my 7. So now you can see the electrons are doubled up. paired up, in fact. So when you see a electron dot structure for any given element, you know, these two electrons up here would kind of be like the s orbital. And then you know how the p has the 3 orbitals that can hold up to 6? That's why we're pairing them up, because they're paired in those orbitals. So the ones that I have here in red would kind of be the p, and then the one up here would be the s. So those s and p valence electrons. Now I want to go to the worksheet, and we just did a couple. So like here would be, let's do this one. Magnesium has 2 valence electrons, so I'm going to go 12 o'clock, 3 o'clock. Let's see if I can say it right this time. Let's do carbon. Carbon has 4 valence electrons. So you're going to use my rules, and then it'll make more sense as we move forward. So I do want to go all those spots, and then I would double if I have enough, which I don't. And then when I get to these, let's do oxygen. So I would go 1, 2, 3, 4, 5, 6. So that kind of gives you, you can fill the rest of that in. And then that's me telling you to take the worksheet out that I hope you have. The last thing I want to do is then start to lead you kind of down the road of chemical bonds. So atoms are going to gain, lose, or share electrons to be very stable. And stable is usually like a noble gas. So they're going to end up not as a noble gas, but they're going to have the electron configuration of a noble gas. So usually that's 8. There's a lot of exceptions, but usually it's 8. And then sometimes it's 2 if it's a really small element. Like helium is a noble gas, and it only has those 2. So when I draw helium, I would draw it 1, 2, but it's going to bond. It's not going to bond, so 0 bonds. So we're going to go fill in the last column of the worksheet in a second. These two are noble gases, and this is where you get that 8. There's S2P6, which adds up to 8. So if I were going to draw neon, I would have all 8 spots full, and those electrons doubled up, 0 bonding. So let's go back and talk about the bonding then. So sodium has this 1 electron dot. It's going to bond 1 time. It's going to try to give that 1 electron away. Magnesium, 2. So all of these in that group are going to bond 1 time. The second group, they're going to bond 3 times. This group 13, remember, it's group 13 on the periodic table. You know, like aluminum, 1, 2, 3, it's going to bond 3 times. Group 14, they're all going to bond 4 times. And then here's where it's not going to be the number of electrons like the previous, but it's going to be the number of electrons that would then complete it to have 8. So like nitrogen has 5, so it wants to bond 1, 2, 3 times. It wants to get 3 electrons and pair up with those 3 electrons that don't have a partner, and then it would end up with a full octet. So oxygen is going to want 1, 2 electrons, so it's going to bond 2 times. Fluorine, 1, 2, 3, 4, 5, 6, 7. Don't watch. I didn't go around and then double because I knew there were 7. So fluorine wants to bond where I'm highlighting 1 time. And then, like I said, these guys do not bond because noble gases are already stable. All right, I hope that helps. And we will talk soon.